this is Ken Rosever, and we're going to talk about summation of index data and what exactly that means. You'll have problems like this, where you'll have some interesting notation, and you'll have to interpret that notation and make a calculation to figure out what this equals. So before you can do that, let me give you some background, some basic information about summation notation and what it means to have index data. The first thing is we have this data in our set. Um, there are 12 items of data, and if I were to index them, I would give them numbers 1 to 12, just like if I had 12 chapters in a book. Each item of data, I would call it an X, but that X would receive a subscript, so I could be specific as to which X I was talking about, because all these are values. They're all members of a sample, and so samples typically are given specific data values in a sample are typically denoted X because they're a variable that's getting measured. They're answering some question. So here we go. So I'm indexing these. Dot, 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 dot. There's 12 of them. Now, summation notation is going to tell me to do something with these. There's two kinds of summation notation, or two kinds of notations that you sometimes see in math. The one you need to know for this course is summation notation. The other one is the big pi symbol, and that's for product notation. We're doing summation because sum we're going to be doing some adding. This is a capital letter S in the Greek alphabet, and when you see something like this, what that is telling you is the sigma symbol means add up what follows. Add up all of what follows. What follows? xi's. Add up all the xi's. But what do you mean xi's? Xi's, x with the index number whatever as the I goes from 1 to 12. So let me say that one more time. This is an interesting little notation. The sigma is telling us to add. The index is telling us to add as the index changes from 1 to 12, this variable that follows with this index. So we're going to add up all the x's as the index changes from 1 to 12. So basically we're going to do this. We're adding them all up. And there's a lot of them. So let me just get lazy. All the way up to x12. Okay? Adding up all those numbers. That would be the sum of all the x's. If this constituted your whole sample, sometimes they get lazy and they just go sum of the x's, and that means we can assume the index is a complete index from 1 to n, however, with n being however big your sample is. So when it is from 1 to n, they leave off the index sometimes. We can view. So what does this mean? Well, x1 is 94, so this actually means 94 plus negative 94, that's x2, plus 28, plus negative 88, plus dot, 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 all the way up to negative 30. So we're going to add up all these values, and that will be equal to this. Now, that's very easy to do in Alex. In Alex, if you want to add up a list, you just click on the list, the calculator will automatically come up, and you just hit sum of the x's, and it'll tell you that they add up to 324. And you'd be done if that's what this was asking for. However, it's not asking for that. It's asking you to find the summation of the 15 times xi as I goes from 1 to 12. So that's a little different. What that's actually asking you to do is this. 15 times x1 plus 15 times x2 plus 15 times x3 plus dot 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 15 times x12. So you're going to multiply each one by 15 and then add them all up. Well, that seems like it's a pain. And it might if you don't know your algebra. It would be a pain. But I think you do know your algebra. And if you know your algebra, you know that a times b plus a times c plus a times d is the same as a times b plus c plus d. That's the distributive property with three terms. Okay, basically I can factor out the a out of each term and place it out in front and just add what's left. I'm going to do the same thing here. I'm going to factor out the 15 and add what's left. What's left, though, is the sum of the x's. So basically, what this tells me is if I can find the sum of the x's, I just multiply that number by 15, and that'll give me my answer. So here in Alex, my answer is, let me click all these again, hit sum, and then times 15 equals 4860. And that's my first answer. I'm going to hit next. It's just going to tell me I did a good job. Very good. Ooh, very good. And I'm going to hit more practice so we can see what other types of problems they have. Now, this one's a little different, but it's not hard because the 6 is outside of the summation. So we're going to do the summation and add 6 to it, or 6 plus the result of the summation. The only question is the index complete? Is it from 1 to 13? Do I have 13 measurements? I do. So I use all 13, which is very quick. I just go like this, hit summation, and I add 6 to that. Plus 6, I get 182. You can do that in your head. 2, and then I hit next. And it'll tell me, very good, you seem to have mastered it. But I don't want to be the master. I'm going to hit it again because I'm going to keep reviewing and I'm going to see what else they have. Now this one, they have a divider, okay? And the index is again from 1 to 12. Let me just show you, on all these problems, the index will be from 1 to 12. But let's say it wasn't. Let's say the index was from 3 to 5 of xi's. The sum is still there, so I'm adding them. So I'm doing x3 plus x4 plus x5. And that's how that would work if the index were not a complete index. I would just take the third, the fourth, and the fifth and add them. So I'd have 28 minus 88 plus 69. And I would get whatever that is. 28 minus 88 is negative 60 plus 69 is 9. And that would be my answer. On this one, the one they just gave us, let's get a new page. I'm going to show you how to do that. They want me to do the sum of the x is over 30, and it's a complete index again. So let me just copy this. I put it in there, and I'm going to erase this. Why did it do that? That was weird. Come on. Okay, and the other thing I'm going to copy is these guys right here, because this will make it very easy to show you if I'm good at this. Now watch, I'm going to move that up, and I'm going to put a little equal sign here. And actually, I'm going to move that up just a little more. Because what this is basically saying, because it's a complete index, is I'm going to take each one of these and divide it by 12. And I'm going to add in between, right? Well, that's a big pain, right? Dividing by 12 a million times. Well, another way I think you can think of that is, since I'm dividing them all by 12, then those fractions all have a common denominator, which is big 12, okay? And if they all have a common denominator, or even if I had 12s under all of them, isn't 73 over 12 the same as 1 over 12 times 73? And isn't 29 over 12 the same as 1 over 12 times 29? So isn't it the case that with these, I can just factor out the 1 over, oh, why am I doing over 12? It was a 38. So these are all 38s. You probably wondered what I was talking about. So basically, when there's a divisor, just factor it out. Take this this is equivalent to, I want to move this, this is equivalent to the sum of the x's over 38. Okay? Let me do one more. I'll do that real quick, and I'm almost out of time. Okay, I sum the x's, I'm dividing by 38, and then I get my answer, and I'm going to stop. There we go.